Welcome back everybody, Professor Blankenship here with another stats video. Now we're going to be taking a look at confidence intervals of the proportion. So in proportion, we're going to be back using our z-table. So just like when we're looking at confidence intervals of the mean with sigma known, we use the z-table. With proportion, we also use the z-table. So in the confidence interval for proportion, our equation is P plus or minus Z alpha 2, or our critical value of Z, times the square root of P times 1 minus P divided by N. So when you're looking for P, P is going to equal X divided by N. So N is your sample size, and X is your items of interest. So let's take a look at an example. So let's say we have an X of 50 and an N of 200. So to find our P, we just take X divided by N. So 50 divided by 200 is 0.25. So now to find our confidence interval of the proportion, the first thing we need to do is make sure that our N times P is greater than 5, and our N times 1 minus P is also greater than 5. Our N is 200 times our P of 0.25, so that's 50 is greater than 5, and 200 times 0.75 is 150, which is also greater than 5. So since both are greater than 5, we can use P as a substitute for pi in order to calculate our confidence interval for the population proportion. So now let's take a look at the equation. So let's say for this equation we decide to look at a 95% confidence interval. So we know that 95% on our z-table corresponds to 1.96. So our equation is going to equal 0.25 plus or minus 1.96 times the square root of 0.25 times 1 minus 0.25 divided by 200. So we can say that we are 95% confident that the population proportion is between 0.1899 and 0.3100. Alright, so now let's take a look at another example. Let's say we have an X of 25, an N of 400, which means that we're going to have a P of 1/16 or 0.0625. And let's say we're going to look at a 99% confidence interval. So we know that on the z-table, 99% in the middle corresponds to 2.575. So this is going to be 0.0625 plus or minus 2.575 times 0.0625 times 1 minus 0.625 divided by 400. So we can say that we're 99% confident that the population proportion is between 0.0313 and 0.0937. So now let's take a look at an example. So a Pew Research Center survey of 4,787 adults found that 4,178 had bought something online in the past year. Now, of these online shoppers, 789 are weekly online shoppers. So now let's take a look at a 95% confidence interval estimate of the population proportion of adults who bought something online. So first we're going to look at our X. So our X is our items of interest. So we have 4,178 items of interest or people of interest. Now our sample size is 4,787. So in order to get our p, we need to take our x divided by n. So we're going to have a p of 0.8728. And now our z, because we're looking up a 95% confidence interval, we know our critical value of z is going to be 1.96. So now we can plug this into our confidence interval of the proportion equation. Here we have our equation, 0.8728 plus or minus 1.96 times the square root of 0.8728 times 1 minus 0.8728 divided by 4,787, which gives us 95% confident that the population proportion is between 0.8632 and 0.8822. So all this is saying is that between 86.32% and 88.22% of adults bought something online. So now let's take a look at a 95% confidence interval of the proportion for weekly online shoppers. So we know that there was 789 weekly online shoppers from the survey. So now we need to find our new p because we have a new x. So our p is x divided by n. So 789 divided by 4787 gives us a p of 0.1888. So we plug this into our formula, 0.1888 plus or minus 1.96 times the square root of 0.1888 times 1 minus 0.1888 divided by 4,787. So we can say that we are 95% confident that the population proportion is between 0.1769 and 0.2007. So if you were the director of e-commerce sales for a company, you could say that based on this information that almost 20% of adults are weekly online shoppers. So you could use this to focus more of your effort on increasing your marketing towards that 20% because you know that they're going to be shopping substantially more than other adults.